All right, so I'm going to illustrate for you today how an ECU will throw a fault for a couple different issues that we may see in wiring or a sensor on a truck or a car. Okay. Today we'll use a very simple two-wire sensor for the most simple explanation possible here. And we're going to talk about how the pull up and pull down resistors work inside of the ECU. So I've got a little board set up. I got 12 volts coming in. There's a 5-volt voltage regulator hiding in behind. And then on this side, we're hooked up to a pull-up resistor. So there is a resistor hiding in behind the ECU. And we wouldn't normally be able to see that. If we were to back probe or test a circuit, we'd be testing at the pins or the plugs or the connector of the ECU. We wouldn't actually take the ECU apart. So this is very similar to what we would be dealing with in the field and what we would be reading if we were to hook up. This is also what the ECU actually reads for diagnosing and knowing what a sensor input reading is. Okay, so we can actually see this resistor. In this example, I've got a resistor in behind here in between the 5-volt reference and the output that we're hooked to. But normally, of course, you would not be able to see this on a vehicle. So one thing to note before I hook this sensor up, we've got an open circuit. So we've disconnected the ECU plug or we've unhooked the pins and wiring for this sensor, and we're reading 5 volts. So this is normal. This is what we would expect to see on a 5-volt reference, and that is what the ECU is reading. So right now, this would actually be throwing a fault. So because the circuit's not completed, because we don't have the sensor in the circuit, it's just open, we are reading a potential for 5 volts to go through it. So we have voltage potential, but we don't have a completed circuit, so we don't actually have current flow there. So the ECU can recognize that. It knows that that means I have a problem. I've got an open circuit, and the fault that it will throw is a high voltage fault because it's basing this diagnosis off of a voltage reading. And it's reading it the same way I've got it here, or the same way you would by pinning out the ECU or by unplugging this sensor and hooking into the 5-volt reference wire terminal, okay, or back probing it. All right. So if we see high voltage there, that means we have an open. So that could be a damaged sensor. It could be a fault on the ground side. It could be a fault on the 5-volt reference supply side. Okay. So a number of things, but a high voltage fault, a -3 fault is what we would get for that. Okay. For an open circuit. So let's go ahead and hook up our circuit or our sensor into the circuit and complete the circuit and see what kind of voltage the ECU will see. And again, this is something that you guys can test as well in the field. You can actually back probe that ECU or that sensor and check that voltage as well. So now we've introduced a variable resistive sensor in here. This is a temperature sensor. Okay. Before we talk about any more about how the ECU knows what's wrong, let's see how this specific sensor basically works. We've got it hooked up. Why not? Let's do it. So just don't mind the heat gun fan noise for a moment here. We'll heat it up and see how the voltage reading changes to the ECU. So we can see pretty clearly that the voltage reading is going quite a bit down as it gets hotter. One thing to note for this, it's never going to go to 0 ohms, no matter how hot that gets or how cold that gets. It's always going to maintain a little bit of resistance. And that's by design. It's meant to be that way because if it ever reached 0 resistance, that would be equivalent to us installing a wire or shorting to ground between positive and ground. We don't want it to be 0 resistance, or that would actually throw a different fault in the ECU. That would be a problem. Okay, so no matter how hot or cold that temp sensor gets or any other sensor gets, it should never have no resistance to it at all. So we could see that the voltage went down as it heated up. What that tells me is this is an NTC thermistor. Okay, and what I mean by that is the resistance is going down. So the voltage goes down. That means the resistance of this sensor has gone down because we're reading before it. The way that I know that is I don't need to save as much voltage here to push through this resistor to get to ground. Okay. So I'm going to show you guys this circuit we've got 5 volts coming in. So this is inside the ECU. And then it goes through a pull-up resistor. So this is the pull-up resistor. All right, and again, this isn't visible to us. This is behind the scenes. The first point of visibility or contact we get for testing is after that resistor. So this could be the pin on the ECU, or in this case, the output to the signal that we have here. Okay, so our little eyeballs are indicating this is where we're reading. And then this here is a variable sensor, and then we go to ground. So we've just created a series circuit, and that's the way the ECU sees these simple variable resistive 2-wire circuit or 2-wire sensors. All right, so it's going to read between the 2 resistors, and the change in that voltage will tell it the resistance value or equivalent resistance of the sensor that's afterwards. So we've already seen that if we unplug it, or if we have an open, if we disconnect this sensor, we should see a high voltage. And again, that's going to throw us a fault. That's going to, obviously the ECU doesn't want to see that. It wants to read this sensor. So if it can't, it's going to get a high voltage fault. We've got an open circuit. I can't read the sensor. It's not hooked up into the circuit. I have a high voltage fault or a -3 fault. Okay. So essentially what we've done here is just created an open. Okay. So it's still going to read the potential for the voltage to carry on, but we don't actually have a circuit to get back to ground. So I've got 5 volts sitting here ready to go, but it can't go anywhere. So a high voltage fault, it's an open. All right. Now let's have a look at another potential fault that the ECU can pick up on, and that is a short. So what we'll do is we'll do what I talked about before. If the sensor were to go to 0 ohms, that would be a problem, right? So let's introduce a wire that doesn't have any resistance. And we can see that the ECU is now going to read 0 volts or low voltage. Okay, so that's going to throw a -4 fault for low voltage, voltage low, shorted to ground. All right, we've got low voltage. And what that means to me is that I didn't need to save any voltage to push through this wire because this wire's got no resistance. I can get to ground without resistance. I don't need to save any voltage. So what we've done here is gotten rid of the resistor after the fact. Okay, but we still got this internal resistor. We just can't see it. All right, so by shorting this to ground, we're not going to actually damage the ECU. It's not going to be a dead direct short in this circuit, but it's going to read it like that. So what that means is all the load's going to get dropped here. All 5 volts will go through this load or this pull-up resistor. Afterwards, we're going to have nothing left because we don't need any more to go through a non-resistive ground wire. Okay, there's no resistance here. I don't need to save any voltage. I have 0 voltage. It all gets dropped here. So that tells the ECU, if it sees 0 volts, that tells it I've got a short to ground. Okay, we can use this for diagnosis purposes too, because let's say we got a bad connection that's introduced a resistor in here. Sorry, my marker's dying here. Okay, if we got a bad connection here, okay, let's say we unplug this sensor and we jump across the sensor. Okay, so we short out the pins of the connector. We bypass the sensor and we try and create a short for diagnosis. We should see 0 volts. We should get a -4 fault. All right, if we see more than 0 volts, that means there's still a resistance here somewhere on the ground path or on the positive side. All right, so now we have to chase our wires and see where the heck is that resistance that's not supposed to be there. Something's not connected very good because I should not need to save voltage to push through a short. I've created a short. I shouldn't need to save it. I'm just connecting wires directly. If I have to save voltage, am I reading here to push through that? That means I've got a resistive wire or resistive connection that I'm not supposed to have.